Good afternoon, everyone. And I am very grateful to the organizers of the conference, as well as the chairperson, Dr. Rana, who has allowed me to present my work today. Actually, this is something different from what was being presented during the morning and afternoon, because actually this was the last moment, because I got the sanction at the last moment because of restrictions. Our institute was not sanctioning the conference at one time. But anyway, I'm here. So I'm just trying to present what work we are doing on plants, some work we are doing on plants which are there present in India. And the title is Study of Phytochemical Antioxidant and Antimicrobial Properties of Chlorophyton Root Extract. And these plants, they grow in India, in the Indian subcontinent also. And these plants, even the roots, the leaves, and in the other parts of the plant are also used as as medicine. They have been used since ages for mainly as an anti-inflammatory, then for other products also, but I'll come to that later on. And why do we need to study some plants is because actually this was an indirect offshoot of what we wanted. We work mainly on parasites, but we wanted to study the effect of some of the root extracts on parasites. However, we were advised that at least it would be easier to go for see the antibacterial effect, because this antibacterial effect nobody had studied at till date in clear terms. And if there is some effective, if it is effective against some of the bacteria, we could go for parasites also. So this is how this work started with us. And our ultimate aim is to study these extracts in various parasites. We are maintaining a lot of cultures like malarial parasite. We also maintain Amoeba, Giardia, pure cultures we are maintaining of these parasites. And if you see, like antioxidant properties are quite well known with the chlorophyton, and these are the studies. And there are some studies where they had shown that in Leishmania parasites, these had some effect also. One was the antioxidant effect, and also in Leishmania also using these extracts of this. This is one of the that we have what we call the Ayurveda, which is actually, the part where it is, you have allopathy and Ayurveda also, and that is a traditional medicine which we follow in India, and there people are using this also. And there you could say they had studied the root extract for immunomodulation for treatment of visceral leishmaniasis. This was again immunomodulation, not really in effect whether it affects the parasite or the bacteria per se itself. So now coming to what this chlorophyton, this is considered to be a very sort of you could say a magic plant if you consider it, because it has multiple effects. Like you see, what people have shown is that it has anti-stress properties, antioxidant also we studied, and people have shown aphrodisiac also. Antimicrobial were not really known, but as I told you, there are few studies. Immunomodulation activity is known, anti-diabetic and analgesic activity, mainly the anti-inflammatory activity was studied at this time. So this has multiple roles as far as this plant was concerned. And if you see the taxonomy, I don't want to go into the detail. This is just to complete the picture where it belongs to. And what objectives we had in the study was the effect of chlorophyton roots extract. You should remember that this is just a crude extract which we are trying to study. Later on we can go for studies if there was an effect as far as antimicrobial and anti-parasitic effect was concerned. And at the moment we are just sticking to the root also, not taking other parts of the plant. So this is how we have actually done the extraction. I'm not very well versed with the extraction, but we have taken the literature. One of our students had done the work, Richa, which I had mentioned in the title. And this is how we had a Solex extraction and percolation extraction. We are using ethanol, methanol, and water extraction for for both this type. And ultimately, we could get 6 crude extracts we wanted to study in this. And this is the methodology in tabular form, what we have done as far as the solute extraction and percolation extraction. This is the temperature difference is there, and the amount of time you require is also different. I don't want to go into the details of this. And this is how we had obtained the plant and then taken out the root of the plant. And this is the just to show you the picture of the solute extraction, percolation extraction, and then rotaevaporator. Using a rotaevaporator, we have concentrated the crude extracts, and then we have used, and then as a milligram crude extract we have used to study the antibacterial and antioxidant effect. So this is just to show you how the phytochemical screening also has been done. And well, again, I would not like to delve into the details of this. This is a standard procedure which is being followed all over. And this is the how an antioxidant activity has been done. Sample has been prepared and DPPH solution is prepared, and this is the methodology which has been used to check the scavenging activity of the crude extract in different milligram amounts. And this is the ferric reducing antioxidant property. Again, this is the second method which is used, and there is a color change in both the systems, and that is how you come to know that this is the amount of antioxidant activity in these. Coming to the antibacterial activity, we have taken strains of the various bacteria, that is E. coli, Staph aureus, Pseudomonas aeruginosa, and these are the main bacteria which we have taken, grown them, and these were obtained from our department of medical microbiology, which is also in the same floor building. And then we have checked the minimum inhibitory concentration of this, and the extracts we have used different concentrations of extracts, different extracts as well as different concentrations of the extracts to see whether there is actually an antibacterial effect or not. So this is the methodology that how it was added into the different media, that is Muller-Hatton broth was used, and this was the final. And then we had grown the bacteria and try to see the inhibition of the bacteria again, because if there is an extract, and then we have correlated the inhibition, we have used another antibiotic, that is ciprofloxacin, just to for comparison what it was doing and what was the comparison with the extract actually. Coming now to the results, this is how the phytochemical analysis, this is to show you the number of alkaloids, tannins, flavonoids, saponins, and steroids. Now this root contains a lot of substances, and those are the ones actually which are thought to have an antibacterial, anti-inflammatory effect, and this has a lot of, this is what actually people have started to study, and some of them have been purified previously also, and they have used it, for example, as an anti-inflammatory agent, or they have used it as, you can say, aphrodisiac and other things they have used in this plant. And this is the alkaloid, how you see tannins, then flavonoids, saponins, and this is the different fractions which have been used. And if you can see that if you do the percolation and different there, because here you see the solate ethanol extract, alkaloids were not isolated, and these are the differences what you do the different. And as far as these were concerned, I mean, if you have an isolation like here, if you do the steroids were only extracted by the ethanol extraction, and this is I mean expected also. So then quantitative characterization was done with the Fourier transform infrared spectroscopy analysis. And then here again for percolation and other method we have done for this different times, and this is the results as far as the of that is concerned. And just to show you the antioxidant properties, if you see here, this is the antioxidant properties in different concentrations, and it is seen that all the extract had antioxidant properties, and this it tended to increase with the increase in concentration of the extract. And this is to show you the color change, and this is say the 25 milligram color change in the antioxidant ferric reducing antioxidant property, and this is the color change from the DPPH assay, where you can see the from purple it is going to yellow when you increase the concentration. This increases the antioxidant property as when you increase the amount of crude extract you are using. And this is just to show you the antibacterial activity of this crude extract. But if you see the red one, which was the most interesting, was that it was the Staph aureus which was inhibited by the crude extract to the maximum, while as expected Pseudomonas aeruginosa somehow was not amenable to the inhibition by this extract. So this is in nutshell what we had seen. Coming to the discussion part was that the root bark extract, the presence of many compounds such as saponins, tannins, alkaloids, which I have already shown you. And these two methods were used to evaluate the extract or oxidant activity. And coming to what actually we had seen, that percolation and ethanolic extracts were found to be the most potent at 25 milligram per ml against scavenging of the oxygen radicals. And the lowest values of MIC against Staphylococcus aureus isolates was 1.5 milligram per ml. Compared to what you could see for Pseudomonas aeruginosa, it was quite higher. And now the, and this shows that the effect of that this percolation ethanolic extract could be one which could be used to further test for other organisms like parasites also. And coming to lastly to the conclusion, we have shown that ethanolic extract is most important for Staph aureus, and this antioxidant activity is also very good antioxidant activity is there, like it is comparable to what you get in vitamin C, and this can also have a powerful effect as far as treatment of, as an adjunct to treatment of infections. And thank you very much. And this is where I come from, that is in North India, and this is the picture of our institute. And we are catering to most of North India and even some parts of Central India. And around we have a registration of outpatient department patients per day. We are having from Monday to Saturday around 10,000 to 12,000 patients per day are coming to our institute. So we have got a huge rush just to this is just north of Delhi, and all of you are welcome to visit. Whenever you visit India, you are welcome to visit our institute also. And this is just in short what we have done. And if there are any questions, they are most welcome.
Thank you very much, Dr. Rakesh. If there are any questions?
Yeah, I do have a question. Thank you very much for this nice presentation. Of your conclusion for the most promising fraction or percolate, do you then plan to further continue to isolate maybe fractions
yes,
and then up to the defined contents?
Yes, that is what we are doing now. We are just in the initial stage, and later on we like to fractionate that, maybe using HPLC or some other methodology, so that when we get the some of the fraction, then the fraction would be checked again for the antibacterial effect, and then out of that it can be easily identified. This is the fraction, and that fraction we'll use. Maybe if we get two fractions which are more effective, that fractions we'll use for subsequent testing of maybe other bacteria plus parasite. Our actual aim is to test against parasite, because like in leishmania and malaria, both of them have become resistant to most common anti-protozoal agents. So what we want, that if we can isolate, some natural product which would maybe not replace the drugs, or it could be as an adjunct, an additional, so that maybe an immunomodulator plus an anti-parasitic agent, which can help to overcome the resistance which we are facing. Like as in the morning also people were saying that it's multiple drug therapy, like for other, even for cancers and other things. Here also, like malaria, everybody knows. Now we are down to we have I mean, we need to have 2 antimalarials to treat the patient. Maybe time will come, we may need 3. So what we need to study is like some more effective therapy. This is just guesswork, but maybe we can be successful in the near future.
As a standard procedure to further fractionate, we also need use column chromatography like with absorbents like
Yes,
silica and
yes, yes, because we are actually, we have got a special instrumentation section. I'm in charge of that also. What we'll use, we have got a lot of equipment there, and we are planning to do that. So this is just the initial identification, and after that, that is what is the plan. Yes.
Is that subject to these natural product seasonal harvest for this product?
Pardon, sir?
Does it changes with when you harvest these root?
No, root, because once the root is formed, then the harvest season should not affect. It will mainly the upper part of the plant that the harvest season should affect. Not maybe the root, because the root forms, I mean, it's, you have seen that.
Sure.
But that's a good suggestion, a good idea. Maybe we can also do something.
Yeah, because some of the natural products
Yes,
subjected to
yes.
season.
That's a good suggestion. I think we can follow up. Thank you.